Hi there. Welcome to Sample Space. In this episode, we're going to talk to Phillip Cloud, who is one of the maintainers behind Ibis. Ibis is a Python project that allows you to write Python code as if you're just talking to a DataFrame, but then you're able to run your queries on many different backends, including BigQuery, Spark, but also Polars and Pandas. It turns out that there are actually a lot of surprising use cases to write data frames this way, and I thought it was a really interesting conversation because maintaining such a project is actually quite hard, and Phillip was able to share some interesting details about that. Now, one thing about this episode is that I did accidentally misconfigure my microphone, but Phillip's voice is going to be super clear, and he will also be doing most of the talking. So I hope that you'll enjoy this conversation where we're going to learn what it's like and what it takes to get a convenient data frame language to run on many different backends. I think you'll really enjoy it. Hi there. Hey, Phillip.
Hey, Vincent. Thanks for having me on the podcast.
Maybe to just kind of get right into it, if you were to explain Ibis, what does it do and what superpower would you say that it gives users?
Yeah, so the sort of the tagline we like to give people, it's like portable Python data frames. I think typically data frame libraries tend to be, they either have their own execution engine like Pandas and Polars, but there's a lot of systems out there that are sort of data frameizable, like basically you could use a tabular data frame API on them, but they don't have a way to kind of execute anything. And so they don't have a way to execute anything like sort of directly from the API. And so I think the superpower that Ibis gives you is like the ability to kind of change your code as little as possible and move from one backend to the other. And I think there's a number of use cases for this, like going from development to production. We have some users who for whatever reason cannot use the production database to do their sort of random ad hoc analyses, but they still need to do those analyses. And so what they do is kind of sample the production system, bring that back locally, iterate on that. Maybe they're running it against DuckDB or Polars or even SQLite, and then you can kind of take that same code, modulo the sort of connection setup, and run it against the production system without having to change anything.
Right. So to come up with an example use case then is, hey, I've got this cute new trick on how we can calculate sessions, but I'm not going to do that on all the user data. Now, you know what? Let's just download everything from yesterday. I want to run that locally. And it would kind of suck if then the code I write locally needs to be totally changed in order to run the thing in production. So then Ibis is kind of the maybe glue is not really the right word, but it gives you like an API that's sort of a standard that can export to different backends. And my impression was that also like a lot of SQL translation happens there under the hood, but you also support Dask, Polars, and Pandas, right? Like those are also supported out of the box, I think.
That's right. We turn, I guess go into some technical detail here, but the way that Ibis works is we have an expression tree that doesn't get evaluated basically until you say, hey, like do the thing, and there's a few ways to do that, but I guess like broad strokes, there's an expression tree, and then we sort of turn that into like something slightly lower level that we can kind of do rewrites and some manipulation of the expression tree per backend, and then we turn that kind of intermediate representation into a few specific targets. So one is SQLglot, which handles all of the dialect translation. That was like a recent big refactor that we did. And then the others that you mentioned, Polars, Dask, and Pandas. In the Polars case, we sort of directly translate to its lazy data frame API. And in the Dask case, it's similar. Like we call into Dask data frame APIs, and Dask data frame builds these these computation graphs under the hood. Pandas is kind of the oddball here in that we kind of directly execute the expression tree. We just sort of the way it used to work was a bit kind of more annoying and complicated, but like we recently kind of refactored the whole execution pipeline, and so now it's just sort of like a topological sort and like fold over, the list of operators, taking the output from the previous and passing that as input to the next, and so on until you reach kind of the root node.
But I would imagine in the case of Pandas as well, like Pandas itself doesn't have any lazy features. I think, like I could be wrong here, but I remember Polars has a lot of them. Dask also has like predicate pushdown and some features that allow you to say like delay the
Yeah,
execution, only run when we need it. But Pandas just runs immediately, right? So I can also imagine just with that in the background, Pandas is kind of the oddball compared to all the other backends you have.
definitely. We don't recommend people use the Pandas backend to start. I mean, it'll work, but it's not optimized basically at all. And so you're not going to get a ton of value from like if Pandas is already kind of working for your use case, switching to the Ibis Pandas backend will probably make you dislike Ibis only because you're adding this extra layer to something that doesn't need it. And so I would definitely like recommend people like tinker with the Pandas backend, but like keep expectations low. And if you want something that's sort of like great feature support, blazing fast, like DuckDB is probably the place to start with Ibis. And you
Because
can
that
execute against data frames, so it's
because that's the default these days, isn't it? The DuckDB backend.
yep.
And
Um,
it, and it's because everyone can run it locally, but it can also handle pretty reasonable data sets as well. I'm assuming that's kind of the reasoning there.
yeah. So at the time, I think we did a blog post on this. I guess maybe we can link it later. The at the time we chose the default, we definitely wanted something that required minimum dependencies, minimum install, and DuckDB is sort of a giant. Well, it's not giant, but it's a statically linked library, so all that gets just bundled into effectively one library artifact. Um, it executes locally. It's parallel execution, vectorized engine, columnar in memory storage, and on disk. It sort of ticked all the boxes relative to any other option we had at the time. Like we didn't have a Polars backend at the time we made that decision. So that was sort of the primary motive, and it basically scales to your hard drive, right? And that's like hard drives are like decently big, at least for an individual user
And
nowadays.
cheap. Let's be honest. Like it's also
Yes, yeah,
nice and cheap,
yeah,
which is also I think the use case for DuckDB. Like if you can solve a whole bunch, everything you can solve on disk is a win.
yep. So like basically being able to there's always been this sort of medium data or medium to medium large
Mm.
data size where it's been really awkward to do your analysis. Like if you got a huge amount of RAM on like some cloud machine, you could probably do it with Pandas. But DuckDB came along and you suddenly like you had the ability, you could do everything a lot faster because it was doing parallel execution. Nowadays it's got very robust like spilling to disk mechanisms. So if you do like a gigantic sort, it's not going to run out of memory. It's going to like it's and it sort of that particular part of DuckDB degrades very gracefully, right? So like it's not going to spill to disk. It's only going to spill to disk as much as it needs to. And then yeah, and so that data size is like right where DuckDB's sweet spot is, and it of course it handles the small data as well.
So one thing I wonder, right? So and this is more from the perspective of a person who hasn't been play. I've only been playing with Ibis briefly.
Yep.
So you mentioned like the first thing you might not do is pandas, and part of me does get that. But one feature I did enjoy a lot was just the idea of well, often when I write SQL, let's say I use BigQuery because that's one of the backends you support. How do
Yep.
I test my query? Like I don't really like if I change the SQL query a little bit in GitHub, then it would suck that I would have to like actually from GitHub CI call to BigQuery to actually run a query to see if what I expect comes out. But one thing I really did like about Ibis is you have a DataFrame like API like from most DataFrame libraries, but at the end, no matter what backend you use, you can always call two pandas, And I
Hmm.
can imagine for unit testing, if only for unit testing, that's already also kind of a big win, right? Like, is that a story you hear often from users, or is that like that felt like the main feature to me at some point? But I can imagine your perspective might differ a bit.
That's funny. Yeah, yeah. So I would definitely agree with that. I think this is a part of the library, independent of sort of how the test suite runs, which is also an interesting topic. The ability to say two pandas on an IBIS expression, if I had to guess, like from the beginning, was like one of the core value propositions of IBIS. Like I didn't start the IBIS project, but I've been working on it for a long time. Wes McKinney created it, so of course, like pandas is going to be in there somewhere, and executing SQL queries, taking them into a data frame, handing them back to users was an important part of the library. And that is in fact how our sort of cross backend test suite works. Like pandas output is either it's like manually constructed, or we like write some pandas code to get the equivalent result that we expect, and then we do like assert frame equal or whatever across for every backend test. And so
Okay,
it's
so
very valuable.
it wasn't just me who figured out like, hey, this is actually kind of sweet for testing. Like the two pandas function is something you actively use internally for testing as well.
Yeah, it's used for nearly the entire backend test suite, and it's actually something we've been considering, like reevaluating, just because of the pandas type system is like not specific enough in a bunch of ways.
Oh, let's go into that. Like, in what sense? Like, I can imagine, is this like a schema thing where some databases have like int 8 and int 16 or something like that? Is that the thing that makes you reconsider, or is it something else?
It's actually like none of the numeric types are all like are fine. There's like two, I think, or maybe three things. One is that there's sort of the automatic promotion to floating point when you introduce like a null value, which itself becomes nan. So like that's an
Oh,
artifact
right.
of not having proper null split. And I know pandas has like two options for that, right? There's like the pandas native nullable D types, and then there's like pyro backed things. Um, so anyway, we're kind of in the process of figuring out whether to use one of those. Then there's string types, which are kind of generic object D types, and probably for the vast majority of pandas code, object D type is holding a string, but because it's so flexible and it can hold literally any Python object, it's fairly expensive for us to like do anything that validates that your data are actually strings. And we do like to have that guarantee in some places. And then the third thing is the complex type support, like arrays, maps, and structs
Ah,
are not really supported in Panda. Like they fall in their object, right? And so there's no
yeah, but
consistent way to manipulate them.
like JSON stuff basically that still has a schema, and you would like to sort of say, well, the JSON that's in here has a certain schema, and
That's
Panda
right.
says, well, it's still just an object, so
Yeah.
that's too broad.
For the most part, that part of Ibis, like we try to go through Pyro for that stuff. And so for the most part, when the data initially comes back from the database to Ibis, like Ibis knows the specific schema. And so there's not a whole lot of, I guess, trouble there. But yeah, there are a few small parts where I think we'd like to have the specific type information, propagated through the result in pandas where possible.
So what this sounds like to me, and this was also like one of the questions I had prepared up front, is I can imagine as like from the maintainer's perspective, you're working on Ibis, and one of the things that is just hard is you're kind of the one thing that glues everything together. Like
Mhm.
if DuckDB has a subtle difference from like pandas, like you're gonna have to figure a way out to sort of deal with that. Except that you're not just dealing with DuckDB and pandas, you're dealing with over 10 backends, I would say. Like the number is probably growing.
Yeah, I think we're
Like
at 20 now. So
so so part of my is that like the hard part of maintaining something like Ibis, the fact that you have to sort of juggle all these different backends together? Would you argue that that's kind of like the challenge of the project, or is yeah? So could you comment on that? I'm kind of curious.
definitely. So one of my colleagues at Voltron Data made the comment that like Ibis is like maintaining Ibis is an exercise in blub studies, which is this Paul Graham notion that lots of software engineering is about like learning a bunch of very specific details about how a thing works. That was a really, I think, astute quote or astute observation, because that is exactly what Ibis is. Maintaining Ibis is about, and it is a lot of what is hard about maintaining it, especially as the number of backends grows. Right, like
To
some,
turn it into a joke, like, what's it like to maintain Ibis? Oh, it's like learning BigQuery, ClickHouse, Dask, Data Fusion, Druid, DuckDB, and all the like. That's kind of the
yeah,
feeling. Is kind of what I'm hearing.
yeah, exactly, and like we too try to either implicitly, because this is a problem that we as maintainers like feel viscerally, we maybe kind of subconsciously select for other libraries that to use to make this easier. So like SQL Glot is a good example of this, where like, yeah, let's leave the problem of like learning all the specific dialects to another library.
That helps to explain maybe like a SQL Glot. That's the translation layer from all these different SQL dialects, right? So BigQuery SQL
Yeah,
is slightly different from Postgres, and SQL Glot can sort of do the translation. That's what you use SQL Glot for, I think.
yeah, and you'll hear people say things like the SQL standard, and it's like, is it?
Yeah, yeah,
you
yeah.
know?
Oh, so what's the biggest difference in those standards? So I can imagine you've got these custom functions. I think, right? I think even on the docs, I read something that DuckDB has specific string functions that you might not have in BigQuery, and kind of vice versa. Like,
Yeah.
would those kind of methods be the thing that makes the SQL translation hard, or is it something else?
Yeah, there's a whole range of like difficulties. So I would say the easiest one is like, oh, Jar-Winkler similarity is called something else in DuckDB than it is in
Like,
BigQuery than it
there's
is
an
in
underscore
Snowflake,
between
right?
two names, and it has to be translated, something like
Yeah, or it's
that.
just called like similarity, or like Levenstein distance is another one. Some people spell it Levenstein, some people spell it Levenstein. Like that's,
Oh,
so
right,
that's like, so
right,
it's
okay,
like silly little, not silly, but like it's like somebody made a choice and like we have to live with it.
right. Okay, but those are easy to cover, right? You can kind of link those names up. That's an easy thing to translate. So I would imagine,
Right.
there's still a reason for it. A library might help, but that's not the hardest thing, I guess, right?
The next, I don't know, there's probably about 4 or 5 categories of things here, but the next thing that's coming to my mind is like operations that are named the same have different relational semantics. And I mean, you might have, so let's consider like maybe two functions that have different semantics but are not, but they're fundamentally just like a scalar function that operates like, element by element on a column, right? So maybe the back end, maybe like DuckDB's default rounding behavior is like different from BigQuery's default rounding behavior. I don't think that's true, but let's say it is. Those are different semantics, but they don't alter, say, the number of rows, or it doesn't change
Oh,
where you can use the function.
so but also things. Does this include things like implicit casting? Like, when do I turn this boolean into an int kind of behavior as well, or is it more subtle than that?
Sometimes it's so the operation I'm thinking about is unnest, which is where you sort of take an array and then you repeat each element once per
Hmm.
row. Um, in some engines, you can actually use unnest in select position. So you can write like select unnest,
Ah,
parentheses
like
column.
that.
And some you can only use unnest as part of a cross join in the from position. And
Yeah,
so
yeah, yeah, yeah.
so
There you
that's
go.
like, it's like in some cases unnest has like has like a column type, and in other cases it's like a table. And so like this is a problem we wrestled with for a long time, and then once we started using SQL Glot actually has like a whole like a rewrite rule that will actually take the select position unnest and convert it into the tabular version. And we were just like, yeah, we're switching to SQL Glot. Like we don't want to solve this
Yeah.
problem.
Well, and also like from the community perspective, you probably want one repository that's exposed to all the edge cases instead of having three repositories across different, user
Yeah.
groups that each report different problems individually. And you kind of want one place where this problem gets solved, I would imagine.
Yeah, and we get the benefit of like the open source development model, because there's so many people who are using SQL Glot for other things beside, like they're reporting bugs to SQL Glot not through Ibis. They're just using it for whatever they're using it for. and we get the benefit of all their input.
Yeah, exactly.
Because
So
we'll discover some of the bugs, and we have done, we have a pretty tight collaboration with the SQL folks, but we're not going to find everything.
like I definitely can imagine that there's like interesting problems that you have once you have an open source project that really tries to be the glue between different backends. And we talked a little bit about this like before this recording started, but like one thing we did mention was that your testing suite, because you're testing not just your own code, you're also testing if your code works on each different backend. And I can
Mhm.
imagine setting that up is kind of a beast as well. Like, could you comment on that?
Yeah, I think so. Ibis started as an Impala thing. Oh, sorry, a project that was mainly focused on Impala. We sort of grew like a SQL Lite thing that Wes implemented. I came along and implemented Postgres, and then it was sort of like the floodgates unlocked, and we needed to figure out a way to test all these things without having to write the same test for every backend. If we'd have to write like n versions of the same test. Even if you solve that problem, you still have an infrastructure problem, right? Like SQLite is kind of similar to DuckDB in the sense that it's, in process, it's just a library.
Those seem easy to test. Like
Yeah,
those
yeah,
are on the spectrum of hardness. Those are the easier ones, I think, to sort of do
yeah,
something with.
right. But then, like, as soon as you move into like Postgres land or MySQL land, or I guess what I would say, like things that make sense to run on a single node and that are like, they're not like it's a well trodden path how to run those things on a single node. At the same time, you don't want all your developers having to like, sudo system cuddle, like fire up a Postgres instance every time they want to test the library against Postgres. So we settled on Docker Compose. That really unlocked the ability for us to test any backend that has a Docker image.
So, and this
Uh,
is for developers who are running things locally. Like I made a change to the Postgres functionality in Ibis. I want to run that test suite locally. Then locally you can run the Compose. But is it also something you run in CI, or is it also run using Docker Compose on your end?
yeah, so that's another thing that I forgot to mention in our kind of pre-record talk is that whenever possible, we try to keep development and like production is not the right word, but like CI on Ibis the same, right? So the Docker Compose that we use locally is the same exact way that we use it in CI. I mean, the only difference being that in CI, each backend gets its own job, right? In sort of the GitHub workflow, GitHub Actions parlance.
Oh, and
Yeah.
also the containers might need to be up to date as well because you get new versions of these containers once in a while, I imagine.
That is semi-automated with Renovate, and
Ah,
so that we Renovate actually does a pretty good job of like I think it's like weekly or something like that. Like, or rather, it runs
so
weekly, and yeah,
what is Renovate? Is that like a GitHub thing, or is that like a separate? It sounds like a cron job that just checks are there new Docker containers, and if so, change the settings. Is that would that describe it?
yeah. I think if you had to distill Renovate down into like a key concept, what you just said is correct. I mean, it does so much more than that, but that is basically its like reason for existence. Um, it does, but it tries to do like it does all the major dependency management tools. Like, so it'll generate a new lock file for you every so often. It will update specific dependencies, like it depending on how you have them declared. You can say, consider a lower bound bump, like not a breaking change. Like there's all sorts of you know complexity there that that does a pretty good job. We've been using it for a long time.
Okay, no, but it definitely makes sense. Like I can imagine the testing here being like a pretty elaborate concern as well, because I can also imagine, oh, a test broke, and let's say it's a generic test that you're trying to test on all the different backends. If you're gonna want to debug it, you almost get back to that. I was making a new feature for Impala, but the Dask thing broke, so now I'm learning Dask. Is that also like part of the experience of debugging, or are there things you've been able to do to make that easier as well?
Yeah, that's a good question. Maybe this is a good time to talk about our 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 special test markers that we have. Because first off, I think most of us perhaps all of us who work at the project are like pretty big fans of PyTest, and we extend PyTest in some interesting ways. And one of those ways is that we have markers that categorize the kinds of failures, or sorry, expected failures for the various backends. So we
So,
have,
and as a marker, you mean like you have a test in PyTest, and you decorate it with PyTest.mark dot, like that's the
yep,
marker you're referring to? Yeah.
yep. So we have not, we have one called like not impl, we have one called not yet, we have one called never, and we have one called broken. And not impl is like somebody hasn't done the work to implement this in Ibis, and perhaps even discover that the not yet marker is more appropriate for this test. And the not yet marker is like the backend or the underlying library like doesn't support this in some way. Um, but it's like, but it might be reasonable for it to do so. So like for example, ClickHouse doesn't support correlated subqueries. That's a thing where it's like a test that tests correlated subqueries would have a not yet marker specifically only for the ClickHouse backend. Um,
So
and
then you have
then
so
yeah,
then you have your generic test, so to say. There's a marker on it, and then from there you can say, well, this is a test for all the different backends, but for ClickHouse in particular, it's fine if it fails. That's kind of the trick you're able to do with these markers, basically.
exactly. And never is like for things that will like probably never happen. MySQL growing support for array types, that doesn't seem like a thing that will ever happen.
Right, gotcha.
And then what was the other one? Broken is for things that like we know are broken. It's a bit of a like heavy hammer. It means it could be broken in Ibis, or it could be like fundamentally broken in the backend for some reason. Well, those are somewhat rare across the code base.
I can imagine. Well, it always comes down to at some point you have to be pragmatic about something, and then sometimes it's better to accept that something is broken than to sort of indefinitely prevent other fixes because you're so focused on this thing that will probably just remain broken. Right? There's some sort of pragmatism I seem to hear.
Yeah, I think it's interesting. I haven't really, I guess, considered pragmatism as like a core value of the project, but I think it very much is in that we're not going to block correlated subquery support for other backends because ClickHouse doesn't support it. We're going to say,
Exactly.
look, this is a feature you can't use if you need to go from X to ClickHouse or ClickHouse to X.
Like one thing I can imagine, like keeping things pragmatic. I'm not the biggest database nerd, so I wouldn't be the best person to ask, but I can imagine sometimes some queries are just better served for some databases than other ones.
Mhm.
Like I can imagine, for example, Postgres. That's kind of meant as a production database, right? Like you're kind of
Yep.
supposed to attach Django to that thing, so you're also writing. You're not just reading and aggregating, so to say. Whereas other backends, they are just way better at aggregating, but they assume that everything's immutable, so to say. Are there considerations there as well with regards to like features that you're trying to expose? Because I can also imagine some databases may not actually be designed for some of these analytical workloads. Like I don't know if that's a consideration as well.
It's not something that we try to address in any specific way in Ibis. I mean, I guess I would say it's like kind of an application level consideration, right? There's certainly certain kinds of queries for which a Postgres or a MySQL is going to be way more optimized, right? If you're doing lots of concurrent small writes are going to be like where those systems really excel, and like giving you strong transactional semantics when you do those inserts or updates. Um,
Yeah, and this is
Ibis
where
is
people like to say things like asset compliant, asset
right,
compliant. Those are the yeah.
exactly. And other, not other sort of like I guess tool like DuckDB and other tools, can also, you can be ACID compliant without being necessarily needing to be like a write optimized system. I would say that Ibis focuses very much on queries that scan all the data, or at least conceptually do, right? Like given a parquet, given like some predicate pushdown or whatever, you may not literally scan all the data, but like nominally you are scanning all the data to get the answer to your query.
Yeah, so there's an assumption that usually people want to do analytics, I guess you could
Right.
say. So that
Yeah.
means that you kind of assume immutable, but you want to maybe go through everything. So in general, you should be able to filter for each row if need be. That's kind of the
Yeah. Yeah. And
ideal
like
use case.
a system like Postgres will also be much better at like needle and haystack style queries where
Mm.
um like on it like you're querying an index column for a specific value. That'll be very fast in Postgres and MySQL. But in in a system like DuckDB, I mean, it sort of starts to balloon in complexity here because DuckDB does have indexes that sort of help with this thing, but they're like a very different style
Yeah,
of index, and yeah,
and then you kind of get back to like the core that's hard about Ibis, which is you're dealing with all these different backends, which I
right. And
guess
so yeah, it's interesting because like sometimes people ask us about performance, and we get questions like we've gotten this question at a tutorial before, which is like, how do I see the memory usage of like using Ibis? And like we hadn't really considered that because all of us had been working on Ibis for so long. We're like, well, that's just not really a thing that you most of the time need to think about. And even if you could, like, there isn't actually a way for you to say, hey, backend, give me the memory use of this
query.
expression because it
Yeah,
may differ each time you execute it for one or another reason, right? Like maybe your RAM is filled up because you've got you've got, I don't know, 500 browser tabs open. You're trying to run this thing. DuckDB's like, yeah, we don't have a whole lot of available RAM, so we're going to start spilling to disk. And then you close those tabs, and now the query's like magically fast. Like that's a weird
yeah.
scenario, but
And there's also like this handoff moment, I suppose, as well. Like if you've generated the SQL, then it's up to the backend to sort of do the optimal behavior, and that's not really something that Ibis should control. I think even because the backend
yeah,
should be
and
good.
yeah,
Backend should be good at that, not Ibis.
we do like to, I guess, really emphasize that like all the painstaking research that's gone into analytic databases and databases in general that you can now take advantage of with IBIS that like may have been a bit inaccessible before uh, for various reasons because you didn't want to like try Postgres and then that doesn't do the thing you want. Now you got to rewrite the query to go to DuckDB, etc. And so it just becomes a lot less frustrating. But you can now take advantage of that, all those optimizations that are kind of happening in whatever fairly often days.
Uh, this is a bit of a brain farty question, and you can definitely tell me if the comparison's a bit silly. But in web land, right? Like you're building a web app, and
Yep.
sometimes people like to complain about the ORM, which is the sort of the Python API, like the object model that can communicate to the database on your behalf. And
Yeah.
IBIS is, of course, a little bit similar, but definitely different. But one thing I do remember from some of the conversations is that some people don't like to write with an ORM. They like to write their own SQL queries because they think they can do it faster than the ORM. Is that something that you've heard as well from IBIS, like in your community? Or is it not really that much of a concern because it's a different workload?
That's a good question. Uh, for the most part, the prominent analytic query engines are very good about dealing with crappy SQL that we may produce. And sometimes we do produce, like, we will definitely add subqueries in places, not correlated ones, just additional subqueries in places where, like, a user might just collapse them. Um,
Right.
but if it's most analytic databases, BigQuery, Snowflake, DuckDB, have very optimized optimizers, and so they tend to be pretty good about doing stuff like collapsing subqueries and like minimizing the most expensive parts of database operations, which tend to be IO. So, like, on the other hand, this big refactor to SQL got led to a bug that allowed that where we were like inlining, everything super aggressively, and so we were generating these humongous expressions that were like 40,000 characters wide, and we were like, well, that's definitely a
Ha.
problem in Ibis, and so like that's a case where like yeah, actually we were generating SQL that like really hurt the performance of this query, and so anyway, that's fixed, but
Right.
but
Right.
that was an example.
So, like in theory, it sounds like in theory it could happen, but in practice it doesn't seem to happen. The backend seemed pretty good at wrangling this.
Yeah, yeah. Because also like humans don't really like humans can also write like bad like non-optimized SQL, and so the database also has a lot of flexibility, right? Because like select statements, which is the majority of what Ibis produces, are immutable and stateless, with the exception of a few,
Yeah,
fun cases like random and some others.
yeah, and also and even in the case where I, as the human, would write a SQL query, would I want to write a SQL query that's optimal or something that I can maintain the next 10 years because it's more readable? There's always considerations in a
Exactly.
way. Yeah.
Yeah, exactly. Like, yeah, you can get into the weeds of like, well, maybe we like, reorder the column this way or what you like. And there's a back and forth with the database as well, right? Like if the database requires some bizarro construction to like be efficient in this way, maybe it's a bug, etc. That sort of.
So, taking a step back, like sort of, I'm reflecting a little bit on my first experience with Ibis, sort of me as a first user. Hey, what could I use it for? We touched a little bit about testing and that you're able to sort of write stuff for different backends and all that. One thing I can also imagine is this is kind of like a nice way to maybe prevent lock-in as well.
Mhm.
Like if I have an analytical vendor and at some point the vendor says, "Oh, you got to pay twice as much." Don't know if this is actually happening, but like it's a fear one might have, right? I mean, if you have everything in Ibis, definitely the transition to another backend should be a lot less painful, right? You always got to migrate stuff, so it's never really a free lunch. But if you have it in Ibis, it does feel like it's an insurance policy. Is that like feedback you've gotten as well, or any comments on that?
Well, I don't think anyone has ever explicitly said that to us. It is something I think we believe to be part of the value add. I think we also like we want to work with vendors, and I think vendors are also seeing the value of being able to have like a multi-component system and not be necessarily like locked into one thing or another, because like let's face it, you ultimately need to get your data out of the vendor at some point to do to build an
Anything.
application, right? Right, yeah, to do anything, right?
Anything.
You're
It has to
you're
be able to
not
go
gonna
out. If it's yeah.
exactly. So like you're gonna need to like turn it into a pandas data frame or a pyr table or a polars table so that you can give it to the I don't know the freaking browser to
Yeah, to make a
visualize the
chart.
thing,
Yeah.
right? Yeah. Um, so there's and be able to do that quickly with standards like Arrow and PyArrow. I think vendors are starting to add that, and so Ibis does kind of help you avoid that lock-in. Um, and like to that end, we don't really prioritize like one backend and another. Like we don't kneecap, backend A because like backend B is like the other cloud version of that, right? Like that's we we sort of don't take a position on that. Like, of course, we all have our individual opinions about which one we like to use more and this and that. But like
Sure, but those are
as a
personal
project,
preferences. Yeah,
yeah,
that's a
exactly,
personal preference versus a project preference, and the project
right,
preference is to just support a lot of stuff.
yeah, exactly. So yeah, if somebody comes along and's like, we need this, we're gonna look into supporting it, kind of regardless of our individual stances on.
So this is, I think, an interesting segue to something else I'm just kind of wondering about because, as you alluded to earlier, when Ibis got started, it was kind of the Hadoop era. We had this project called Impala. It was SQL, and we wanted some way to talk Python to it. And because we could already do a little bit of SQL, or maybe Postgres, we can add that, and then SQLite, we can add that. But there also comes a time when at some point, some people like to use BigQuery and DuckDB comes around. And I can also imagine you cannot just go ahead and accept everything that comes in or everything that's sort of new and out there. So, like, what's that process like? Like, how do you choose a new backend to add? Do the vendors come to you, or is there a plugin thing people can try out first? Like, how does that work?
Um, there's a bit of history here. I hope it's yeah. Let's maybe just
Let's do
delve
that.
into that for a second. For a long time, like we sort of had everything in Ibis. Um, all the backends were there, and then this was I don't remember when it was a while ago, 6 years ago maybe. And then we sort of I think collectively decided to split things out and make backends pluggable. development of Ibis kind of went, dormant for a couple of years. We still had this, and then when I joined Voltron Data, we started investing a lot of time, money, and effort into the project, and we needed to do quite a lot of refactoring, and it became pretty burdensome to have these third-party backends because we were making breaking changes pretty often, and the third-party backends like couldn't really, they didn't like either have the bandwidth to keep up or like for whatever, it wasn't like a huge priority. So we ended up bringing everything kind of back into the main repo, um, and that's how it is now. So you asked about like, do vendors come to us? Sometimes they do. Sometimes it's users, um, who like individual users. It's hard to tell. We don't necessarily require that somebody say, "Hey, I'm from X organization. I would like this backend." The main consideration for whether we add a new backend, I think today, is like whether we have the capacity to support it.
But
And
that is a very serious consideration as well, because you will always have not enough manpower to support every backend out there. So you got to pick,
yeah,
I would imagine.
exactly. So there are a few, I guess I would say, like softish criteria when we consider adding a new backend. So if it's something that can run like on a single computer, and it's not like a client server model system, it's certainly easier for us to say yes. That's not necessarily a guarantee we're going to say yes, but it makes the whole thing much easier because we don't need to spin up any infrastructure or maintain configs or blah blah, sort of deal with that. Um, if it is a client server system, it's basically a requirement at this point that there be a Docker image that we can access publicly, like either from Docker Hub or whatever, some other container server thing. They're also like, if it's our client server things tend to be SQL based, and so there also needs to be like a minimal DB API implementation for that. And then cloud services are probably the toughest for us to accept as like if somebody, like for us to do the work, I mean, like if somebody else wants to like submit the PR to add that backend, then it's, a little bit easier to justify it. But cloud services tend to be the most difficult because yeah,
Is that because of the testing? Because I can imagine the testing, like if you can run it in a Docker container, you can do your generic testing trick as you've mentioned, but you cannot run BigQuery in a Docker container, as far as I know.
that's right. So there's a lot more bureaucracy is not the right word, but there's a lot more process overhead to like that requires like interacting with humans, right? Like I as a developer need to say, "Hey, person who has like permission to this thing, like can you add me to the project?" And then if after that it doesn't work, then you have to like you kind of go through a debugging cycle. And so it ends up being more difficult to develop that back end, unless you're in, the group of people that has access to it. That's another thing. Like we have a BigQuery instance that's actually sponsored. Like Google pays for that, which is, thank you Google. That is great. But like even as an open source project, we can't just open that access to that to the world, right? I mean that,
No,
yeah,
then you're asking for trouble.
right. So if it's a Docker container, like anyone, any person at their local computer can just pull that from Docker Hub and do the thing they need to do.
Yeah, no, that makes sense. Okay, no, so I can definitely imagine that BigQuery is kind of an interesting exception because I can imagine there's so many users, but quite obviously it doesn't run in Docker. So, like testing that, you will probably need some help from someone who
Yeah.
understands BigQuery very well. That'd be kind of the way forward.
The other thing we look for is like whether the project is relatively active, right? We don't have a strong criteria, but if it's been 7 years since the
Nice
last
commit.
commit, then and like I said, it's kind of fuzzy, right? Because we do have some exceptions to that, like, the Impala and Impila are not seeing a lot of development these days, but we haven't gotten rid of the Impala backend. It's relatively like low maintenance effort because it's not
Yeah.
changing very
If it doesn't change much, you also don't have to do anything on the Ibis side.
often. Right.
Okay,
Yeah.
interesting. Makes sense. So there's a little bit more towards the future then, and I'm about to ask a few questions that are kind of out of curiosity, and the answer might just be no. But I
Sure.
read on the Polar's blog the other day that NVIDIA is collaborating with them to add GPU support
Uh,
to Polars. And you kind of go, all right, there's going to be interesting things you might be able to do with that. But how does that work with Ibis then? Maybe in the future, like I can also imagine Polars not being the only project that might do something with GPUs. There might be more groups doing it. Like, is that something you also see on the horizon? There is that like DataFrame's are also changing, is what I'm kind of asking.
yep. Yep. Definitely. We definitely want to support other hardware, I guess, paradigms, even mixed sort of paradigms where possible. We we are kind of experimenting with the adding a backend using UDF, CUDA based DataFrame library. NVIDIA actually wrote a CUDF backend based on like a slightly older version of the Pandas backend because they have this cute import hack that replaces all import pandas with import CUDF for better or worse. And so they were able to get a working Ibis CUDF backend without without us having to do anything using that. So that is out there. I personally have not tried to use it, so I don't know where it's at in the development. But we also want to support that, like sort of explicitly on our side. Um, and of course, like Voltron Data's Theseus product is well within that domain of things on
But then I guess
GPUs.
it's so it's definitely on the roadmap of interest, but it's more of a question of, hey, are there implementation details? And for that, you have to kind of be exposed to the problem a bit more. So depending on
Yep.
how Polars might do GPU, then you might be able to adapt. But we're not at the point yet where we can sort of predict very well where that's going to go. Also on your end.
Yeah, I think there's a testing issue. I mean, it's not particularly easy to get like a cloud GPU machine. I mean, it's easy enough to say, hey, Google or Amazon, like give me a GPU instance, but like you might just get like, hey, we don't have any of those right now, right?
Uh,
Um,
so okay, so this is I have to reflect here and do observe that a lot of what we're talking about in the end is how do we test Ibis? Like the GPU, no, and like to me that also felt like one of the bigger challenges of the project. So it doesn't surprise me that much, right? But
yeah.
like it is an interesting observation. Like yeah, the GPU stuff sounds super interesting, but how do you test it? And that's like the first thing that hits you in the face in a way for a
Well,
lot of these things.
yeah, I mean, we also want to make sure that people are not using a broken piece of software because we're like whatever, test and prod.
Yeah.
Um,
You want to be a
yeah,
serious project. You can't YOLO through all the vendors out there. Like that's not
right.
the way to do it.
It does it does. I think you're right in that a lot of a lot of our criteria for sort of like whether a backend gets in or like considerations for just general development are like, well, what does the testing look like? Because it's hard to actually run this test suite across all these backends in a way that is manageable by developers and like actually giving us a useful signal about whether the thing is failing. And like we used to have a different set of like PyTest markers that were not useful. Like they would just skip stuff that would sometimes work or like skip things that we should know are failing
but
for specific reasons, right? And
like
so
every
yeah,
test will be marked as flaky, and therefore, if it failed, you didn't know if anything broke. Kind of like that.
exactly. And so
Yeah.
Gil Forsyth, one of the maintainers of Ibis, when he joined Voltron Data, went through and like he was like more or less single handedly like added these markers to Ibis because of this reason. I think he was observing some funkiness that was like, "Hey, this actually works. Like, why aren't we testing it?" And then it was like, "Well, this is actually broken. Why aren't we testing that?" And so now
Yeah.
it's so that bit of the fact that we have to consider testing so much is definitely an inherent problem to the project, mostly because of the
Well,
cross backend thing.
yeah, but that's also, but yeah, and that's also kind of the beauty because that's how I experienced it. The cool feeling that I got when playing around with Ibis is, oh, someone else is doing that for me. Like the fact that
Yeah.
I don't have to worry about my queries being cross-compatible and there's like a huge suite of tests. That might be the service that this open source project gives users, right? And lots of other things sort of pour out from that. Like you can also use it for unit testing. You can also use it to switch providers if need be. But the fact that it's tested, that might argue like that green tick in GitHub, that's like 80% of the value, maybe.
Yeah, and we've actually had a few requests to like make it possible to run the test suite against an external backend, which I'm sure you can imagine is
Interesting.
pretty gnarly because our test suite is just not set up to do that at the like
Yeah.
sort of Ibis tests as a library.
Interesting. I mean, I can't imagine if you're an analytical provider. Oh, if you pass all the Ibis tests, that's a nice signal you can tell your users in a way.
Right.
But but testing is also so hard to do that right because you want to be pragmatic, but at the same time you want to test the whole spectrum. So, like, how long does your CI run? Like, if you do like a commit, like how long do all the tests run?
Okay, so I have a blog post on this as well.
Oh, okay, that's it. That
Because
wouldn't surprise me. But
after every push to main, we actually or maybe no, sorry. Every day at some predetermined midnight UTC or something, we actually take all of the GitHub CI run data and like dump it into a cloud storage bucket as JSON. Uh, and then we have a couple of like it's all stored in BigQuery. Actually, we have it stored in BigQuery. We have like a couple of kind of you can kind of create a view on your cloud bucket so that you're not actually storing the data in BigQuery. You're just sort of running queries on it. BigQuery is pretty good at that. And so I create a blog post to look at our CI performance over time because it was starting to get crazy. It was starting to get like an hour to run the whole thing. And around that time, like we switched to Poetry to manage packages, and that allowed us to do some dependency caching. So we didn't have to do the full solve of every thing, like every, the entire environment, which you can imagine is pretty big. And if we just have that lock file in the repo, it's basically just downloading at that point. So it's like limited by bandwidth. You don't have any you spend no CPU doing a SAT solve problem.
yes, well, and also I have the blog post in front of me. I think it is the one blog post on Ibis that has the dog fooding tag, which I do think is a like very appropriately named tag in this particular case. It really looks like a good blog post too. By the way, like I'm just glancing over the charts here, but it does seem like there's interesting stuff.
So we look at
Worth
that
reading.
we look at that every so often, and um, I would say that like I think circa that blog post, which I think is probably over a year old now.
Yeah,
Uh,
January 2023.
yeah, I think it was somewhere between 10 and 15 minutes to run all the backends except for the cloud ones. And the cloud ones don't run on PRs because they require credentials, and so we only run them against main, and there's like a special label that maintainers can use to kick them off in a PR. But like, if you came along and made a PR, we're not going to run,
Yeah.
we're not going to run things because anyone could just echo the creds or whatever. And so anyway, uh, 10 to 15 minutes is what I'm going to say. I don't know the number off the top of my head now. It might be longer.
Sure. No,
I don't know.
I've seen project where CI can really easily take an hour, but I can imagine in this case, because you already mentioned you have your Docker Compose that can sort of split it up, and then things run in parallel. Like that'll make a huge difference.
Yeah, you want the individual. The point of that blog post is like you want the individual jobs to be fast, and you need to be running a bunch of them at the same time. You're going to be bottlenecked on one or the other dimension depending on where
yeah.
what your limitation is.
The slowest running CI job is the overall determining factor for like how quickly you can hit that merge button.
Exactly. And
What
so, yeah, go ahead.
so as I read the blog post, I guess there's like one sort of maybe interesting thing, also a little bit more in the direction of wrap up, but something that I tend to ask a lot of project maintainers is there is this point where you're a maintainer of an open source project, And there is a point where you're also still a user of an open source project. And when I read the dogfooding tag, I was actually kind of triggered.
Yeah.
Because is that something you experience as well? Like, surely you use Ibis somewhat regularly. I would imagine. But is there also like, do you also experience this thing where sometimes it helps to take a step back from the maintainer's chair and just be a user for a bit, just to sort of still have it in your fingers what it's like to use the tool? Is that like something you've experienced as well?
Oh, absolutely. Every time I write a blog post where I have to solve an actual problem and not just work on a library, I am in that position. And so I think a few members of the team do this on a somewhat regular basis. The product manager, Cody Peterson, I mentioned him earlier. He does this on a very regular basis, and so the dog fooding post is something I wrote, and there's also another post I have that's sort of showing like the same expressions running on DuckDB and BigQuery, where I was like looking to see like what I was looking at IMDb data, and I was like, what who are the I forget exactly what the question was. So it was around like who does like a lot in the film industry, like who's like a director, actor, producer, et cetera, like all the sort of positions one can hold on a movie, those sorts of things, and then
Yeah.
yeah,
So,
so
so
it's
you kind of look for like fun sort of queries to write, and like preferably ones on somewhat big data sets, and then every like once a month on a Friday, you kind of have a field day with stuff like that. That's kind of
yep, yep,
the way to
and
do it.
I think writing docs, or so we use Cordo, which has been like a boon for the project. One of the things that you can do with Cordo is like you write inline Python code and then it's executed and rendered, right? And so you 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 never have to worry about this problem of like, are my docs gonna be out of sync code wise with my library? If the
Yeah.
thing doesn't run, then the docs are broken and you have to fix either the docs or the library.
Yeah, so I've been an R user before as well, and this is like it smells like an R Markdown document in a way. And I
It's kind of the growth of, or the next evolution, I guess, of that.
Exactly, but you also and you compare that to a notebook, and you compare that to some of the doc tools we have in Python. I'm also a fan of MakeDocs, but I did have to write my own MakeDocs testing library to run the actual Python code in each code cell to sort of give
Yeah.
me a signal if it's broken. And
Yep.
my impression from Quartor is that some of that stuff is just kind of built in, and it feels fairly mature because of stuff like that.
Yeah. Cordo uses it's kind of a giant chimera of like 7 or 8 different pieces of software, but like rolled into one convenient box. So everything's like powered by Pandoc under the hood in Cordo,
Yeah.
and then that's sort of like rendering. It's like calling into the Jupyter kernel, then rendering it, and like you can mix R and Python kernel. It's like it's
So
wild.
I apologize for the pun, but you could say that Pandoc is kind of like the Ibis, but for like text documents, because it can sort of
Yeah,
move from PDFs to Word and from Markdown to HTML and all sorts of direct. Like that's what Pandoc does, right?
yeah,
In
it's
a
sort
way.
of like bag of adapters pattern, right? Where you're like,
Yeah.
I would say Ibis has far, far fewer A to B,
Yes.
things
Yeah.
than
That feels
Pandoc,
fair.
but
That feels
uh,
fair. So I guess like a final thing that I'm just kind of curious in this case because you've been working on Ibis for a couple of years now, is my impression at least. So like you've got your knees deep in data frame stuff. From your perspective, like what is interesting about the future of data frames? Like what's something on the horizon that kind of excites you, where you kind of go like, okay, the data frames were already fun, but this is going to make it like even more.
I guess I'll just talk about what I've been playing around with recently, and that's like Pyodide, which is this Python interpreter in the browser, and powered by WASM. And I think that one of the exciting things about that is basically just the ability to like do your analysis in a browser tab. You don't really have to think too hard, at least initially, at about package management, or whether like things are sort of in the right environment and you're activated. You have like a kind of a browser tab open, and you can just sort of sit there and do your analysis. Being able to do data frame stuff in the browser in Python is is pretty is pretty exciting. I think it's going to make things really, really fun.
I can also imagine there's like a couple of these websites like Kaggle where you have to download the data set before you can actually play with it. It will be really cool if you can just say, oh, here's a repo with CSV files, and you click a button and you can play from it from the browser. And then whoever's hosting the data set doesn't pay for the compute, but you can just immediately play with it. Like, there's definitely cool stuff on the horizon for that. Yeah.
Yeah, and I think there's been a bunch of, maybe not a bunch, there's been a few players in this space like Binder, but Binder has like really, really long build times. And there's always the sort of like hosted notebook option. But the hosted notebook option, right, like requires like a client and a server, and well, there's always going to be a client, but it requires like a server and a machine to host that server. Right.
Yeah.
Right. Exactly. We could just throw it under the bucket of backend stuff, and like Pyodide is like, well, you don't really have to think about that, to a first approximation. Yeah, if you're going to be running on like GPUs and this and that, I mean, okay, maybe even that's like up for grabs. But
we have web GPUs now, right? Like technically,
right? So
if you can really WASM it, right?
So yeah, I guess if you could like, I haven't actually experimented too much with Emscripten, but in theory, if you can use Emscripten to compile CUDA, I feel like I'm talking out of my butt.
Yeah.
Like,
well,
it's like
one can dream. Let me put it that way. Like
exactly. So if that if that's possible, maybe that's on the table. But yeah, you basically have a level of infrastructure that for a good chunk of analyses, are not. It's no longer necessary to run like a server on a cloud machine somewhere or whatever. You fire it up in the browser and kind of get your thing done. Whatever you get done.
Yeah, and there's definitely like an accessibility win there as well. Like you don't have to download the thing; you can just run it.
Yeah,
cool.
Yeah, and we're going to add that to the Ibis website at some point soon, and people will be able to try it, in the browser. But don't run it on mobile, I guess is my my first piece of advice there.
Okay, cool. Now then, yeah, so once again, from my end, like it was definitely fun to play around with, so I can definitely recommend more people having a look at Ibis. I will add, we referred to some articles in this piece, so we're going to add that to the show notes. Philip, I guess like a final question, if people want to find you, maybe reach out to you, what's the best place for them to find you?
Definitely GitHub. Spend most of my workday on GitHub. I have been dabbling a bit in tweeting, mostly about the things I work on. I have a YouTube channel called Phillip in the Cloud. It's not super active at the moment, but stay tuned.
Cool, happy to hear it. I mean, and thanks for all the work on Ibis. It's a fun project, and people should definitely check it out. Have a good one.
Yeah, thanks for having me on, Vincent.
Thanks for listening to this episode of Sample Space. The podcast is still a little bit in the experimental phase. This is definitely still my first time making a podcast. Sorry again for the audio quality there. But moreover, we're also experimental because we're still trying to figure out who to interview. If you happen to have an opinion on that, maybe you know of a great open source library in our field that deserves a little bit of extra coverage, then do let us know. You can connect to the Probabl social media accounts on Twitter or LinkedIn to reach out, but you can also reach out to me personally if you have a lead or an idea worth sharing. Once again, thanks for listening, and I hope you'll stay tuned for the next episode.